All right, here is our warm-up. You may want to copy this down and hit pause. Okay, now let's get to work. So I've got x over 2 equals uh, x minus 2 over 3. So the first step is we would cross multiply is one way we could do this, and we would get x times 3 equals 2 times x minus 2. If I'm multiplying 2 times all of this stuff, I need to put the x minus 2 in parentheses. Now, the first thing I'm going to do is I'm going to do distributive property with the 2, so 2 times x and 2 times negative 4. So 2 times x gives me 2x, 2 times negative 4 is going to give me negative 4 here. And now I'm going to subtract 2x on both sides of the equal sign to make this go away, because 2x minus 2x is going to go away. And then 3x minus 2x is going to give me x, and we get x equals negative 4. You may want to hit pause and replay this if you have troubles with this. Okay, next. Please make sure you have colored markers to help with your notes. It makes a big difference. Okay. So the first question we did in today's activity was how far are you from the string base? Okay, so here we have a person, and you've got this wall, and you've got this base right here, and you've got a string that's attached to the wall. So you've got this fixed triangle, and you're moving forward until your top of your head touches the string, okay? And you want to know how far you are to where the string's tied to the ground and where your feet are. Okay, I'm going to call that x, okay? And you're given that this distance is 155 inches, this distance is 84. On your paper, it may be different on the computer. And anyways, so the first thing to do to solve this is envision that you've got two similar triangles. So here's the first triangle with the person, right? And then here is the triangle with the wall, right? There's the wall. And both triangles are made with the same angle here, okay? And so you can set up these ratios with 55 over x and 84 over 155, and now we can solve for x, right? We can cross multiply, you get x times 84 equals 55 times 155. If I cross multiply, okay, and then, so 55 times 155 is going to give me 8,525. And then, so in order to solve for x, now I'm going to divide by 84 on both sides. That's going to make this go away, and then I end up with x equals 101.5. So what does that mean? So 101.5 is the distance that the person is standing away from the string where it's tied. Okay. So you may want to hit pause if you need more time to copy this down. Okay, so now there's some important definitions that we need to get. Okay, so when you got a right triangle, the angle that we're going to be referring to is called the reference angle, and sometimes the reference angle is here, sometimes the reference angle is up here. For now, we're going to be talking about the reference angle being at the bottom. Now, whenever you've got a reference angle, the side that's farthest away from the reference angle is called opposite, and the side touching the reference angle is called adjacent. Okay, so you need these definitions. So the side farthest away from the reference angle is the opposite side, and the side closest to the adjacent angle, the side closest to the reference angle is called the adjacent side. And as always, the hypotenuse is the side that's across from the 90-degree angle. Important notes. Okay. So now let's look at some of the examples that we might have done in class here. So all of these people have the same height. I just made them the height of 2 lines on my notebook. Okay. Now, as you can see, these green lines keep getting shorter and shorter and shorter. Okay. As they get shorter and shorter and shorter, what happens to the reference angle? So you can see here's the angle. It kind of looks like it's getting bigger, doesn't it? So first of all, the person's height is opposite of the reference angle. Okay, the orange line is far away from our reference angle, right? And the distance between the string and the person, that's the green line here, is the adjacent side. Okay, so what we just said, what happens to the reference angle as the adjacent side gets shorter? Well, this angle is looking bigger. And now let's look at this for an exaggerated example. So here I've got a reference angle here that's really, really far from here. So if I put my protractor here, and I've lined up the circle and the line here with my ground line, you can see that it looks like it's about 10 degrees. And if I put this circle here and I measure the angle, it looks like it's about 55 degrees. Okay, so here we've got 10-degree angle. We've said this guy is 5 units high, and if it's going to be 10 degrees, if I measure it, I'm going to get 28. If it's going to be 55 degrees, if I measure this, I'm going to get 3.5. So you would all agree that 10 degrees is smaller than 55. So when I set up a ratio, we're going to be using this ratio, the opposite side over the adjacent side. We're going to be using that ratio this whole month sometimes. Okay, so the opposite side over the adjacent side, how does that affect our reference angle? Well, let's look at it here. If my opposite side is 5 and the adjacent side is 28, then I'm going to get 5 divided by 28, which gives me this decimal that's pretty small. So whenever you've got a small angle here, whenever you got like 10 degrees, then the ratio of opposite and adjacent is going to be a small number. Okay, now what about if we've got a big angle, like 55 degrees, if this angle is 55 degrees, then once again, the ratio of opposite over adjacent, 5 over 3.5, I get a bigger number, which is 1.429. And whenever the ratio is 1.429, you're going to get an angle of 55. Please make sure you copy these notes down very carefully. It will help to use colored markers. And that's it. And we'll be working on this for a whole month. So please be careful copying it down carefully, and you will learn more about this month.